I'll be going over the umpire steps for the rotate matrix problem. So for this problem, you are given a n by n 2D, array, matrix A representing an image. Then we want to rotate the image by 90 degrees clockwise. Clockwise. You need to do this in place, so we want to update the matrix A. And then if we end up using an additional array, you will only receive a partial score. So I think actually we don't even want to use an additional array. Like if we look at this part here, you should perform this operation in place using only constant memory. So yeah, we don't even want to use an additional array actually, we just want to do it in place. And it has to be constant memory as it says. So for the first step, the understand step. So we're given a 2D array, then our output, just we want the rotated 2D array by 90 degrees. So let's see. So for the first example, so we're given the array 1, 2, 3, 4. And then the array becomes 3, 1, 4, 2. So if we look at the array, we have swapped elements, right? Or I mean it's rotated, so 3 becomes the first element, 4 becomes the third element, 2 becomes the last element, and 1 becomes the second element. So we have rotated the array in this case. Then in the next example, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And the solution of the rotate array becomes 7, 4, 1, 8, 5, 2, and then 9, 6, 3. So in terms of matching, what first comes to my mind is like swapping elements. And we'll be doing a variation of that, but what I think really works, it's like the easiest for this problem is really just transposing the array, and then we reverse each row. So for this problem, I just want to transpose the array, and then reverse each row. So in order to do this, my plan is that I'm going to have to loop through the 2D array. We want to store the first element, a temporary variable. Then afterwards, we want to replace the element that we're at with the element in the column, or the element that we're at in the first row with the element in the next row. Then after that, we'll swap the element that we swapped with the element in the next row. We'll store it in we'll swap it with a temporary variable, so the element in the first row that we saw. So we're just swapping each element in each row, and then it'll do it by indexes. So we'll basically just swap each element. We'll try to keep like these diagonal elements the same, but then to get it to the right order, we're just going to reverse each row. So basically we're just like swapping elements. So let's say we have 1, 2, 3. Then so we have 1, so we're not going to swap that with anything because it's part of the diagonal part of the 2D array. But then 2 will be swapped with 4. And then 3 will be swapped with 7, right? So the rows are basically becoming the columns. And then the columns are becoming rows. So we store the first element in a temporary variable. Then we want to swap that element in the row with that element in a column. So we'll only do this if it's not part of the diagonal. And then to finally get like the correct array that we want, we just want to reverse each row of the matrix. And then after looping, so after we do this loop, we'll have another loop where we do another loop where we reverse each row in the array. Okay, so let's see. So for implementation, for implement, so we just want to start by looping through the 2D array. So for I in range len a, and for j in range I len a, we want to store the first element of the row in a temporary variable. So we store that element in a temporary variable. Then we swap that element in the row with the element in the column if it's not part of the diagonal. And then after doing that, we'll swap the element in the column with the element in the row, which we have stored in the temporary variable. Oh, whoops. I'm doing column and row, but this is ing, but probably be better just to switch it for I and this column, and then there should be a row. And then, yeah, we'll just store that with the, we'll just swap that with the element we have stored in the temporary variable. Then after doing all of this, we just want to reverse the rows in the array. Then for this one, we do have to return a, I believe, yeah. So we return a, but this should be our modified array. Okay, so let's check it out. Nice. Passed all those test cases. Submit it. Cool, so we got it correct. So yeah, we just transpose the array. So basically, we swap the rows and the columns. So rows become columns and columns become rows. And the only things we don't change in this array are the diagonal. And then after doing that, after swapping them in that way, we just loop through each row and reverse them, and that gives us the rotated array by like 90 degrees. So in terms of evaluate, I think for time, this is definitely O n squared. We have to use 2 double for loops. I mean, we're working with 2D arrays, and so I think it always ends up being O n squared for the most part. Then for space though, we just have like temporary variables. We don't use like any extra space. We can't create another array, so this just ends up being O of 1. Okay, thank you, and that's my umpire process for rotate matrix.